A comparison of methods for calibrating SWMM rainfall runoff models using genetic algorithms, supervised by Dr. Usman Khan and Everett Snyder, and presented by Karen Abogadil. With precipitation comes evaporation, groundwater replenishment, transpiration, surface runoff, and eventually condensation. This is the hydrological cycle, and this is what SWMM tries to simulate. SWMM is the most widely used numerical model for simulating urban runoff and drainage, and it stands for Storm Water Management Model. As you can imagine, all the details about a specific watershed are often unavailable or incomplete. A typical SWMM project will have hundreds to thousands of subcatchments and more than 20 parameters for each subcatchment. Simulating this environment requires a lot of parameters to demonstrate the complicated relationship between rainfall and runoff. Calibration involves changing these parameters to make sure the predicted runoff matches the observed runoff. Some parameters will make sense to change, but others won't. Calibrating these models manually can be labor-intensive and time-consuming. This research aims to automate this process through genetic algorithms. Specifically, this research focuses on which rainfall events should be used for calibration. A quick literature review will show you the inconsistencies in the calibration procedures used. More importantly, there is no consensus on which rainfall events should be used, which is problematic because the type of events can vary from single rain events, multi-events, continuous time series, and more. Even more inconsistencies exist in defining what constitutes a single versus a multi-rainfall event. Why is this important? Urbanization leads to higher impervious surfaces, which in turn lead to an increased runoff volume that is 2 to 6 times higher compared to pre-urbanization runoff levels. Rainfall runoff models are important for city planning, design, and management of water resources, and especially important for when this becomes this. Accurate runoff predictions can help the city prepare for potentially damaging flood events. Calibration is required for accurate runoff predictions, and yet there is still no standardized way of calibrating a model. To demonstrate this problem, I created a SWMM model consisting of a simple watershed area with 3 subcatchments and 1 rain gauge. Using the 2005 rainfall data from Humber River, various rainfall events were applied to this watershed. Specifically, 3 types of events are applied. A single event isolated from other events by at least 12 hours. Shown below is the predicted surface runoff for each subcatchment. Next, a multi-rainfall event was applied. A dry period of 48 hours was inserted between each rainfall event, and below is the predicted surface runoff. And lastly, a continuous time series data was applied. Here, the full 2005 rainfall data was used, and again, below shows the predicted runoff. It is clear that applying different rainfall events produces different runoff values. We can further compare the surface runoff error, observing larger error with larger rainfall data applied to the model. Though all parameters were kept the same, how the rainfall was applied affected the output. The typical SWMM calibration procedure includes the following steps. First, the model is set up, creating the watershed of interest. Then, simulation is performed by applying rainfall data. The resulting runoff predictions are then compared with the observed data. Functions that measure the difference between the predicted and observed are known as objective functions. SWMM calibration will minimize these, and the values serve as performance measures. This is then followed by a sensitivity analysis to help find which of the countless parameters are sensitive enough to cause changes in the output. Depending on the results of the analysis, the sensitive parameters will then be updated, and the process goes on. The model shown in this presentation was a simple watershed and therefore does not have observed values to compare to the output. Calibration of the SWMM model will ensure the predicted runoff matches the observed. This research aims to measure the effects of different rainfall events on performance and calibration, with the end goal of a standardized method for calibrating rainfall runoff models.